11.1b homework. So we're going to add some multiple of equation number 1 to some multiple of equation number 2 in order for these to eliminate. The least common multiple of a 1 and 2 for the x is a 2. The least common multiple of a 4 and a 5 would be 20. So since 2 is smaller than 20, I probably want to eliminate the x's. So I want the x's to have a 1 leading coefficient, or a 2 leading coefficient, sorry. So I'm going to multiply the 1 by a 2. Now, both the x's in the top, number 1 and number 2, are both positive. So I need to multiply that by a negative 2 so they have opposite signs when I'm done distributing the negative 2. So now I say negative 2 times x is negative 2x. I say negative 2 times positive 4y, which is a negative 8y. I say negative 2 times negative 13, which gives me a positive 26. I add those together, and I say 2x plus negative 2x, 5y plus negative 8y is negative 3y plus, then we say, so again, 5 plus negative 8 is negative 3, and then negative 17 plus 26 is going to be a 9. Then we undo the multiplication of y by negative 3 by dividing by 3. Whatever we do to one side, we do to the other. It gives me y is equal to negative 3. Then we have to use that y is equal to negative 3 in one of the previous two equations in order to solve for x. So I'm going to use the first one, which is x plus 4y, y being negative 3, equals negative 13. 4 times negative 3 is negative 12. So we have x plus negative 12, or x minus 12, is equal to negative 13. We undo the subtraction of 12 by adding 12, and whatever we do to one side, we do to the other. That gives me x is equal to negative 13 plus 12, which is a negative 1. So that means our ordered pair must be negative 1, negative 3. So we're going to solve the system by the elimination method, and then checking the answers. So we have a least common multiple between a 1 and 3, which is a 3. For the x's, we have a least common multiple between a 5 and a 4 of a 20 for the y, so we probably want to get rid of our x's. So what I want to do is I want to multiply equation number 1, the one on top, by a 3, but not just a 3, because the positive x on top and the positive 3 on the bottom are both positive. I need to multiply this by a negative 3 so that they end up with opposite signs. Okay, so we distribute this. Negative 3 times 1x is negative 3x. Negative 3 times 5y is negative 15y. Negative 3 times positive 10 is negative 30. And then we add those together. So 3x plus negative 3x cancels out. 4y plus negative 15 is negative 11y. 8 plus negative 30 is a negative 22. So now we undo the multiplication of y by a negative 11 by dividing by negative 11. And whatever we do to one side, we do to the other. It gives me y is equal to a negative 22 divided by negative 11 is a positive 2. Then we go back and we plug it in. X plus 5y, y being 2, is equal to 10. 5 times 2 is 10. So we end up with x plus 10 is equal to 10. We undo the addition of 10 by subtracting 10, and whatever we do to one side, we do to the other. It gives me x is equal to 0. So the ordered pair is 0, 2. So we want to solve the next system by the elimination method. So we have a 7x and a negative 11x. So the least common multiple between both of those would be a 77. We have a negative 11y and a positive 22y. The least common multiple between those two is going to be a 22. So we probably want to eliminate the y's because they have a slightly lower LCM, or lowest common multiple. So I want to get this 11 to turn into a 22, and I do that by multiplying by 2. Now, the sign on this one is a negative, the sign on the other one is a positive. They're already opposites, so I don't need to multiply this by a negative 2. I need to multiply the first one by a positive 2. I like the signs, I want to keep the signs. So we say 2 times 7x is a 14x. We say 2 times negative 11 is a negative 22y. We say 2 times negative 35 is a negative 70, and then we add them together. So we say negative 11x plus 14x is 3x. We say positive 22y plus negative 22y. Those cancel out. We say 55 plus negative 70 would give me a negative 15. I undo the multiplication of x by 3 by dividing by 3. Whatever I do to one side, I do to the other. Negative 15 divided by positive 3 is a negative 5. Then I would plug the negative 5 back into one of the original equations. Doesn't matter which. I'm going to do the first one because why not? So we say 7 times negative 5, 7x, so 7 times negative 5, minus 11y is equal to negative 35. So 7 times negative 5 is a negative 35, minus 11y is equal to negative 35. Then we would say we want to undo or get rid of this negative 35 by adding 35. And whatever you do to one side, you do to the other. It gives me negative 11y is equal to, now this is going to be a 0 because we're saying negative 35 plus 35, so those just disappear. And then we undo the multiplication of 11 by dividing by negative 11. Whatever we do to one side, we do to the other, giving me 11. Y is equal to a 0. So the answer to this one is a negative 5, 0.